Welcome back to Algebra 2. These are both equations that we used in the last chapter. Please pause, think about which equation you're using. What do you use for n if you are using the specific compound interest formula? And then when do you use the equation with e? Pause, take the time to do these now. And I think I might actually have you upload these. Okay, so these are going to be uploaded. Your deposit is the same for every time, so P is 7,000. We're going to have 3 years, so T is 3. And then we are going to have quarterly rates. So in quarterly rates, your N is 4. And the rate, remember you always have to convert by moving 2 spaces over, so 0.0126. And you should get $7,269.23. Then compounded monthly at a higher interest rate, compounded daily, use 365 days for that. Continuously, you are now switching over to this equation here with E. Annually, and continuously with a lower interest rate. Okay, so please make sure that you're uploading your work on those for the bell work as we move on. Our objective for the second part of this is to be able to divide and simplify rational expressions, including listing the domain limits. What we need to remember is copy dot flip-flop. So when we have two fractions, rational expressions, and we are dividing, we are going to copy the first term exactly, change division to multiplication, and flip the second fraction. So copy dot flip-flop. Once we do that, the steps are going to be the exact same that we did in the last section. So we have a quotient to find, and we do want to factor out any kind of greatest common factors. So on the first term here, I'm going to go ahead and write it out as 7x, and I'm going to go ahead and factor out a 2 here. So I'm going to have 2 and x minus 5. Okay, that's the copy part. Dot, change to multiplication. And now when I flip this fraction, the numerator now goes to the denominator. So I'm going to have x squared minus 6x. I am going to have to factor something out of that. And in the top I'm going to have what was the denominator. Now we're going to keep going on that, and we are going to factor these two terms here. So now we're ready to factor the numerator. Factors that, add to negative 11 and multiply to 30, so they're both going to be negatives. And 3 and 10 would not work, 5 and 6 would work. Then we're going to factor out the second one. And x comes out of this. So let's see what all we can clean up. I see an x minus 5 in both. I see an x minus 6 in both. I see an x, and we canceled a lot. So we're left with 7 over 2. But we had a whole ton of things in the denominator. We started out with these two things in the denominator, and that's going to mean that x minus 5 cannot equal 0. When this was in the denominator, x minus 6 could not equal 0. And then when we switched, we also have this x here not equal to 0. So everything that was originally in the denominator and everything that changes into the denominator, so all of the factors of all of these three spots cannot equal 0. So in the end, x cannot equal 0, 5, or 6. Next problem. Remember that when we are dividing by something that looks like a whole number, we're going to put it over 1 to start with. And as we go, I'm going to factor out some things. And this one here is going to be a little bit harder to factor. So I'm originally going to look for factors of 90 negative 90 that add to give me 1. So that is going to be plus 10, and I'm going to put it in the numerator, and minus 9, and remember that I have to put a back. So you have several different methods that you can factor those out. I am going to simplify those fractions. Then in the denominator I have 4x squared. So now I need to dot, flip-flop, 1 goes in the numerator. And can I factor anything out of this guy? Well, yes, I can. I'm going to factor out an x, and I'm left with 3x plus 5. So here's where it's actually useful to try to simplify these things and not leave them in this format. Remember that I try to simplify these guys. So I'm going to simplify the fraction as much as I can. And 2 goes into both of these guys. So I'm going to have this as 5 over 3. And the 3 moves in front of the x. So that guy really is 3x plus 5. The second term, those are both divisible by 3. So now the 2 comes in front. 2x minus 3. And in the denominator, I have 4x squared times another x, so that becomes x cubed, and 3x plus 5. Okay, so these two actually do cancel. They're hard to see when they were in the original form up here. There are advantages to putting it in factored form and not solution form. These both cancel, and we're left with 2x minus 3 and 4x cubed. Now, what cannot equal 0? The original denominators. Now, this one was 1. 1 doesn't equal 0. We're good with that. And then both of these guys here are now in the denominator. So both of these end up giving me 0. They were just two different locations that we had that. Then this one ends up being negative 5/3. And do leave as a fraction. Okay, again, we're going to do the copy dot flip-flop. I am going to factor out anything that I have a chance to. So I have 4x, and I'm going to factor out a 5. Then we have to go for our dot and flip-flop. So I'm going to go ahead and start factoring these things. But this guy has to go into the numerator. So the denominator goes into the numerator. So factors of 8 that add to give me negative 6 are going to be negative 4 and negative 2. Then what I can factor out of this guy, I'm going to factor out x, and I get x minus 2. So everything that is in this term, and this term, these are all divisible. Jazzy came back in again. These are all things that cannot equal 0, but we can simplify this a lot. So x minus 4 cancels, x minus 2 cancels, x cancels. Now they don't all simplify this much, but everything that was an x simplified out, but we do have to have our limits. So x minus 4 cannot equal 0. Both of these x minus 2's cannot equal 0. And x cannot equal 0. Giving us cannot equal 0, positive 2, or positive 4. And our last problem, remembering that this is actually in the numerator, so when we copied off flip-flop, it will change positions. And we again have to factor this out, so we're going to find factors of negative 10 that add to give us 3, and that's going to be positive 3, so it's going to be 5 and negative 2. So I'm going to start out with my factors of the numerator. X plus 5, divide by whatever a was, and x minus 2, divided by whatever a was. So both of those clean up. We're going to have the 2 in front, and x minus 1. Denominator, 6x. That was the copy. Dot. And the flip-flop, we're also going to factor these guys as we go. So the 1 now goes in the numerator. And both of these, I can factor an x out. And that's going to give me 2x plus 5, which, because I wrote the top one in factored form and didn't leave it this way for the solution, I do recognize that those cancel. Now the x's don't cancel because they're both in the denominator. So we end up with x minus 1 over 6x squared. Well, it does look cleaner than this guy. And the last thing that we need is everything that is or was in the denominator cannot equal 0. So 6x cannot equal 0. X cannot equal 0. And 2x plus 5 cannot equal 0. So that means that x cannot equal 0, or this one comes negative 5 over 2. Okay, so do the extra step of copied off flip-flop and make sure that everything that is in these 3 positions cannot equal 0. Okay, your next assignment is going to be on Google Classroom with just the division problems, and I believe I'm going to have this one due on Monday. But do make sure that you uploaded your bell work. Have a good day.